Think about the last time you bought a set of tires for your pickup truck or the family SUV. You probably spent a Saturday morning at the local shop, maybe dropped $600 or $800, and felt a bit of a sting in your wallet as you drove away. Now, I want you to imagine a different scenario. Imagine you're standing in the middle of a copper mine in Arizona or a coal field in Wyoming. You're looking at a tire that stands 14 feet tall. It's wider than your living room. It weighs 6 tons, and it costs $60,000 minimum. Some of the high-end versions, the ones used on the absolute largest haul trucks, can top $100,000 per tire. That's not a typo. One single piece of rubber costs more than a brand new, fully loaded Range Rover or a luxury Mercedes sitting in a showroom. Welcome back to Motor Vibe Talk. Today, we are dismantling the staggering economics of the most expensive rubber on Earth. We're going to look at why these 6-ton giants aren't just big tires, but are actually some of the most complex engineering masterpieces ever built. We'll look at the thermal stresses that would melt a normal tire in seconds, the proprietary chemistry hidden in the rubber, and the terrifying financial reality of what happens when one sharp rock causes a $60,000 sidewall to fail. The price of immortality. When you see a Michelin 5980 R63 tire, the gold standard for ultra-class haul trucks, sitting next to a luxury SUV, the scale is almost comical. The SUV looks like a toy, but the price tag isn't the joke. Why does a tire cost as much as a house? It starts with the sheer scarcity of the means of production. You can't just go out and buy a machine that molds a 14-foot-tall rubber carcass. There are only a handful of factories on the entire planet, mostly owned by Michelin and Bridgestone, that have the physical capability to build these units. The molds themselves are multi-million-dollar investments that take years to design and commission. Because the production capacity is so limited, mining conglomerates don't treat tires like parts, they treat them like a precious metal commodity. During mining booms, the global supply of these tires dries up so fast that used tires with 50% tread can sell for more than their original retail price. I've seen mining sites that have hundreds of millions of dollars tied up purely in tire inventory, stored in climate-controlled warehouses, because a single year of sun rot on a tire that size is a six-figure loss. The chemistry of extreme pressure. Now, let's talk about the magic mud. If you took the rubber from your car tire and tried to put it on a Caterpillar 797F haul truck, it would catch fire before you even finished your first load. When a truck is carrying 400 tons of rock, the pressure on the bottom of the tire is immense. But the real enemy isn't the weight, it's the heat. As the tire rolls, the rubber constantly flexes and deforms. This creates internal friction, which creates heat. In the industry, we call this hysteresis. If that heat builds up too much, the internal temperature of the rubber can exceed 200 degrees Fahrenheit. At that point, the chemical bonds in the rubber begin to break down. The tire starts to turn back into a liquid state from the inside out. In the worst-case scenario, the gases inside the tire can actually ignite, causing a catastrophic internal explosion that has enough force to flip the entire truck. To combat this, manufacturers use proprietary synthetic polymer blends. This isn't just rubber, it's a cocktail of natural rubber, high-grade carbon black, and secret synthetic compounds designed to dissipate heat as fast as possible. These formulas are more closely guarded than the recipe for Coca-Cola. A single degree of temperature resistance can mean the difference between a tire lasting 6 months or 6 weeks.
The steel spine. Behind that rubber is a skeleton of pure steel. If you were to strip away the rubber from an ultra-class tire, you would find miles and miles of high-tensile steel cable. In a standard car tire, the steel belts are thin and flexible. In a mining tire, the bead, the part that holds the tire to the rim, is made of steel cables as thick as your wrist. The carcass, or the body of the tire, is woven with enough steel to withstand a gross vehicle weight of over 600 tons. When you consider that a fully loaded haul truck is basically a mobile apartment building moving at 30 miles per hour, you realize that the tire has to be a structural component as much as a traction component. It's a pressurized vessel, a shock absorber, and a structural column all rolled into one. The precision required to weave that steel into the rubber without creating air pockets or weak points is why the manufacturing failure rate has to stay near zero. The high stakes of vulcanization. The making of these tires is a slow, high-stakes game. Once the tire is built, which means the layers of rubber and steel have been hand-assembled on a giant drum, it has to be cured or vulcanized. For a car tire, this takes a few minutes. For an ultra-class mining tire, it takes over 24 hours in a massive pressurized oven called an autoclave. During that entire day, the temperature and pressure have to be perfectly controlled. If the temperature drops by just a few degrees for 10 minutes, the chemical reaction won't complete properly. The result? A 6-ton pile of scrap rubber that cost $100,000 to make and is now worth absolutely nothing. This is why quality control is so intense. Manufacturers use industrial X-ray machines and ultrasound to look inside the rubber carcass before it ever leaves the factory. Any microscopic defect, a tiny bubble, a stray piece of wire, results in a 6-figure write-off. There is no grade B tire in the mining world. It's either perfect or it's garbage. The logistical nightmare. Even getting the tire from the factory to the mine is a feat of engineering. You can't put a 14-foot tire in a standard shipping container. They are shipped as break bulk cargo on specialized ships. Once they hit land, they require specialized trailers and escort vehicles. In many parts of the world, moving a set of these tires requires a police escort and the temporary removal of power lines and road signs just to clear the width. The freight cost alone for a set of 6 tires can exceed the cost of a luxury car. And the challenges don't end when the tire arrives. Mounting these tires is a dangerous, specialized job. You don't use a tire iron, you use a specialized tire manipulator, a massive piece of heavy equipment that looks like a forklift with giant crab claws. If a bead isn't seated correctly and it pops during inflation, the shockwave is enough to kill anyone standing within 50 feet.
The financial impact of a puncture. This is the part that really hurts the bottom line. Imagine you're a mine manager. You've just spent $300,000 on a fresh set of 6 tires for one truck. An hour into the shift, the driver runs over a stray piece of jagged flint or a discarded drill bit. A single sidewall puncture can instantly vaporize the daily profit margin of an entire mining site. Unlike your car tire, you can't just put a plug in these and call it a day. While section repairs are possible, they are a complex science. You have to grind out the damaged rubber, weld the steel cables back together, and re-cook that section of the tire with a specialized heat blanket. It takes the machine out of service for days, and even then, the tire is compromised. Because the stakes are so high, 2026 has brought us into the era of the digital tire. Most of these tires now have sensors embedded directly into the rubber carcass during the manufacturing process. These sensors monitor the internal temperature and air pressure in real time, beaming the data to a satellite. If a tire starts to get too hot, a computer in an office halfway across the world will alert the driver to slow down or take a break before the rubber reaches the point of no return. The future of massive mobility. As we look toward the future, the industry is trying to move away from traditional pneumatic tires altogether. We're seeing a shift toward airless honeycomb structures and 3D printed tread patterns. Why? Because the global push for green energy is ironically creating a tire crisis. To build electric cars and solar panels, we need massive amounts of copper, lithium, and rare earth minerals. To get those minerals, we need more haul trucks, and those haul trucks are currently facing a massive tire shortage. The most expensive rubber on Earth is currently the fundamental bottleneck for the global energy transition. You can have all the lithium in the world in the ground, but if you don't have the tires to move the trucks to get it out, it stays in the dirt. Final thoughts. The next time you're driving down the highway and you see a massive piece of heavy equipment being hauled on a trailer, I want you to look at the tires. Don't just see them as wheels. See them for what they really are. $60,000 engineering marvels that are under more stress than a jet engine. They are the unsung heroes of our modern world. Without these 6-ton rubber giants, we wouldn't have the minerals for our phones, the coal for our power, or the steel for our buildings. They are expensive, they are temperamental, and they are incredibly dangerous. But they are the only reason our global economy keeps rolling. It really puts that $800 set of tires for the family SUV into perspective, doesn't it? What do you think? Is it time for us to find a better way to move 400 tons, or will the big rubber always be the king of the mine? Let us know in the comments below, especially if you've ever worked in a tire shop or on a mine site. We want to hear your stories of the big iron. If you enjoyed this deep dive into the staggering economics of the mining world, do me a favor, hit that like button. It helps us keep the lights on here at Motor Vibe Talk. And make sure to subscribe so you don't miss our next look at the machines that move the world. Thanks for hanging out with us, and we'll see you on the next one.